Welcome back, kindergarten students. Today we are working in science on Unit 2, Pushes and Pulls, Lesson 6, Investigating Motion Portfolio. My name is Mrs. C. Today I'll help you complete this portfolio so you can turn it in to your homeroom teacher for a grade. This portfolio has many steps, so it's okay if you complete it over 2 or 3 days. I'll complete the entire project with you during this video, but you can come back and watch it in different parts. All right, before we begin, let's start by looking at your lesson to see our objective and key words. Our objective is what we want to do. In this portfolio, you will think like an engineer about designing an object that can push another object in changing directions with changing speeds. Here are the key words. Direction, the path that an object moves in. Pull, a way to move an object toward you. Push, a way to move an object away from you. And speed, how fast or slow an object moves. Remy has a problem. She looked in her closet. It's a mess and there's too much stuff. What can she do? She's going to design a storage bin, so like a little box that can go under her bed. So we are going to do a very similar project. It says she needs to make it easy to pull and push the bin, and it can move in any direction and more than one speed. So look at that closet. Whew, it is a mess. Here's a question you can talk about with your learning coach. How will a storage bin solve Remy's problem? How can you solve a problem like too much stuff? You can solve a problem too. Engineers follow steps to solve problems. So right here is our anchor chart to show us the steps that we can take to plan out an object. This object will help us store your stuff. So the first step you can see right here is ask. That's where we're going to begin. Ask questions. The first step is to ask questions. You can ask the 5W and H questions. Who, what, where, why, when, and how. Here's a video that you can watch to learn more. All right, so here are some examples as well. These are some answers to questions, and these are some questions at the bottom. You can use some of these questions if you would like to. Some of these might be the same questions you have. When can we start? Why do I need it? How can I solve the problem? Where will it go? What can I make? And who can help? You can use some of these same questions if you would like to for your asking questions. So we're going to use this concept web to help us organize our questions. Let's see what it looks like. Here's the storage bin concept web. I have this linked in the description if you need it, or if you have it in your science journal, you can complete it there. So I'm going to show you my completed concept web. This is going to take care of the ask step in that engineering process. So here's mine. My questions are not exactly the same as the ones we just reviewed, but they are similar. So yours might not be exactly the same either, and that's okay. For my who question, it says, who has a box I can use? For my what question, what size is best? Where? Where will it fit? When? When will I use it? Why? Why do I need it? And how? How can it move easily? So these are my questions that take care of the asking portion of the engineering process. You can print this out and complete it on this concept web as well. You can use a blank sheet of paper or you can use your science journal. All right, let's go back to your lesson and see how we should keep moving forward. Think like an engineer about building a storage bin. You can solve a problem. You will, number one, ask questions about bins. We already did that. Number two, brainstorm bins that fit under a bed. So that's when you're coming up with ideas and trying to figure out ways that you can make that engineering project. Number three, design a bin. Number four, Create a bin that you can push or pull. Number 5, design an object that can push and pull a bin in changing directions and with changing speeds. Number 6, test your bin and pusher. And number 7, improve your bin and pusher. So here are some of the things that you can record in your science journal. We already began with the questions. Now we're going to move on to that brainstorming. You will write in your science journal and you will show pictures of your work. You will send them to your teacher. Here is a very helpful rubric that we will review at the end that will help keep you on track to make sure that you're doing all of the parts you need to do to help you get the best grade possible. We have a new objective. In this section, you will brainstorm or think of ways to create an object that can push another object in changing directions and with changing speeds. Here are those keywords again. Direction, the path an object moves in. Pull, a way to move an object toward you. Push, a way to move an object away from you. And speed, how fast or slow an object moves. Remy needs some ideas. Remy has a problem. She has too much stuff. She wants to make a storage bin. The bin needs to fit under her bed, to have handles, something to push it at changing speeds and direction, and something to pull it at changing speeds and direction. She also needs a lid or top, and maybe it can have wheels. So down here, there are some ideas that she has in this image gallery. You can look at all of these ideas, but she says none of these worked, so she wants to design something new. What does Remy do next? She can brainstorm new ideas. In this section, you will think of many ideas. Do not decide which ideas are good or bad, just save them all. So here we are. We've already asked questions. Now we are brainstorming. How do you brainstorm? Well, you need a lot of ideas. What do you do? Watch this video and answer the question. So watch this video and it will talk about brainstorming solutions and then talk about this question with your learning coach. Who can you get to help you brainstorm? All right, so now we are going to answer some questions. Why do we brainstorm? Which ideas should you write down? And how can you start with a question? We are going to do all of this on our next page. Remember, you can always ask for help. That's okay. You can have someone help you write or draw the ideas. But do not judge any ideas as good or bad. They're all good, right? They're all new and interesting ideas. List as many ideas as you can and use this storage bin brainstorming T chart to write or draw your ideas. Let's see what it looks like. So this is our storage bin brainstorming T chart. You can see it's separated into two sections, a needs column and an ideas column. So you can make this on plain paper, you can complete this in your science journal, or I have it linked in the description if you would like to print it, or of course you can print it right from the lesson as well. Let's look at the one that I've already completed. Here is my storage bin brainstorming T chart. Here are the things that my bin or my box needs. It needs to fit, right? It needs to go under a bed. It needs to be strong so it can hold all of those heavy toys, and it must not break. I don't want it to pull apart and make a bigger mess that I just cleaned up, right? Here are my ideas. I thought I can add a string to push and pull my box. I could also add tape to reinforce it and make it stronger, right? So those sides don't cave in or break. So those are my ideas, and here are my needs. You need 2 or 3 things on each side of this. More than that, if you have more ideas, that's fine. Less than that, you might not get the best grade possible. So make sure you have at least 2 or 3 on each side. All right, let's go back to your lesson and see how we should keep moving forward. We finished our T chart, and now we're moving on. Here's a new objective. In this section, you will design an object that can make another object move in different ways. Here are those same key words. Direction, the path that an object moves in. Pull, a way to move an object toward you. Push, a way to move an object away from you. and speed, how fast or slow an object moves. So if you want to take a break and maybe pick up tomorrow, that is perfectly fine. We've already completed 2 worksheets and 2 steps, so this is a really good pausing point if you would like to finish your work tomorrow or the next day. If you want to keep moving on, let's see what we're going to do next. Design. Remy needs to plan. So she wants to make that storage bin and she must plan a design. It will show how she can push and pull the bin from under her bed. The bin will move in changing directions and it will move at changing speeds. Here are some ways she can make a plan. So you can make a chart, you can make a checklist, you can draw a picture. All of these are great ways to begin your planning. Now you will plan the design for your bin. You will draw your bin, you will draw what you will use to move your bin, and you will decide what materials you need. Now we're on this designing section of the engineering process. So talk about these questions with your learning coach. What problem is Remy trying to solve? And how will making a checklist help Remy plan her design? What change did you make to your plan as you worked? So when you begin designing, are you going to change anything? Maybe you decide you want to make something different or better. Whatever your idea is, you can try it out and design it and test it and see if it works or not. Sometimes it will, sometimes it won't. All right, so on this paper, the draw and write section, we are going to draw a design for your bin and we're going to talk about how it will move in changing directions or speeds. So if you click right here, there's a printable option. It's also in the description if needed, or if it's in your science journal already, you can do it right on that page. So we're going to draw and write. Let's see what this worksheet looks like. All right, so you're going to draw your picture right here. And then down here, you're going to write just a simple sentence or two about your design. So let's look at my completed example that I have done for you. Here is my design, and you can see I labeled it a lot. Labels are where you show what the things you have drawn are. So I've got my box in the middle. It's open. You can see my toys inside. I've got rope or string attached to the ends. This is the rope to pull it one direction. This is the rope to pull it the other direction. So it's on both sides. And then the flaps, I'm going to push those down. That way it stays closed and that way my toys don't fall out and it doesn't get caught on the top of my bed. So I've got pushing. I'm going to be pushing down on the top and pulling. I can pull it one direction or the other direction. Here are my sentences at the bottom. I will push the top of my box to close it tight. I will use string or rope to pull my box. So to pull it out from under the bed or to pull it further under the bed so I can get it stored. All right, so that is what you're going to complete next. You're going to draw your design. And then after you draw your design, you're actually going to make your design and see if it works. All right, so that's the end of this section. But like I said, this has many parts, so we're going to move on to the next one now. And we're going to complete this portfolio assignment. It's thinking. Here's our new objective. In this section, you will create an object that can push another object in changing directions and with changing speeds. Look, we have some new keywords. Material, the matter used to make things, and plan, actions to take to do something. Remy creates a model. Remy thought about some ideas and she picked one of them. She made a design, she got materials. Now it is time to create her storage bin. Remy will start with a model. If the model works, she will build the real thing. So a model is just like a smaller version of what you want to make. Sometimes it helps to build a model first and sometimes it doesn't. Accessing and evaluating information is a 21st century skill. Remy looked at information from different places to plan her storage bin and an object to push or pull it in changing directions and with changing speeds. She built a model first. This way she can know whether her design will work. If it works, she can build the full-size storage bin. If it does not, she can make changes and she can try again. This is all part of that engineering process. Look, we're on the next step. Create. In this section, you will create your bin. Here's that anchor chart again and a question that you can think about. How can planning help you create your storage bin? Steps in creating. Remy wants to build a bin. She made a plan. She made a tool to push and pull it. It can go under the bed. It can change directions. It can change speeds. Now she will create her bin. How can she do this? Watch this video and see. After you watch the video, ask yourself, what can Remy do if she needs help building her bin? Why did Remy set goals? Why did Remy hang her drawing up? And what change did you make to your bin as you worked? All right, so we are going to use a timeline. That way we can plan out how we're going to design our bin. So we've got our design, we've got our picture, but now we need steps. We need things in order for what we're going to do. So we're going to draw or write the steps that we use. If you click right here, there's a printable version of this timeline. It looks just like this. You can see in this column, we're just going to number our steps, 1, 2, 3, and so on. And right here, we're going to say what we did for each step. So here is my example for you. Number 1, I found the right size box that could hold the amount of toys I had. Number 2, I got some string. Number 3, I cut the string. Number 4, I tied it around my box. And number 5, I used tape to make it stronger. That way it wouldn't break when I was pushing and pulling it. So that is the next worksheet that you're going to complete. And remember, all of these are going to get turned into your homeroom teacher, so make sure that you're completing all of those along with me as we move forward. Here's another example if you'd like to see the example in the lesson as well. All right, now we've already done our design, we've created our bin or box, and now we will test an object that can push another object in changing directions and with changing speeds. Here are those keywords again. Direction, the path that an object moves in. Pull, a way to move an object toward you. Push, a way to move an object away from you. And speed, how fast or slow an object moves. Remy tests her design. She needs to push and pull the bin. She plans to use a curved umbrella hook to hook the handles on her bin. So she's going to use this little part right here to grab the handles, to pull it or to push it. She can push and pull with the umbrella handle. She can change the direction the bin moves, and she can change the speed the bin moves. But Remy must find out if it works. She must test what she has made. Remy will use hard pushes. She will use soft pulls. She will write down what she sees. So how can she test her design? By actually doing it. Testing is the next step. Now you will test your bin. So we've moved from create and on to test. We've already got our box or our bin. Now we're going to see if it works. Think about these questions. What are you testing? How will you know if your design works? And how will you test your design? So right here, we've got a 2-column chart. We're going to write down our observations or what happens when we use those hard pushes and pulls and those soft pushes and pulls. If everything goes right, we're good to go. If anything goes wrong, we can make some improvements. So if you click right here, you'll see this printable worksheet. Or you can complete it in your science journal if you have it there, or you can just make a chart like this on a piece of plain white paper. That is fine too. So here's our type of test. It's already written for us. We have a soft push, a soft pull, a hard push, and a hard pull. Over here, you're going to write a simple sentence. It doesn't even have to be a complete sentence, although it's always really good to practice in complete sentences when you can. And you're going to write your observations or what you see happening during your test. So here's my example for you. With a soft push, my box moved slowly. With a soft pull, my box came out easily, out from under the bed. With a hard push, my box tipped over. And with a hard pull, my box tipped over again. So my box, it didn't work out that well for those hard pushes and those hard pulls. I'm probably going to have to make some improvements. Let's look at your lesson and let's see when we can get to improving. So this is the last section. In number 2, we're going to go to section 3 now, and this will be the last part of your portfolio. We've only got 2 more parts left. In this section, our objective, or what we want to do, is to improve an object that can make another object move in different ways. The direction is the path that an object moves in, and the speed is how fast or slow an object goes. Remy improves her design. She tested her design, she used a soft push, she used a soft pull, and it worked. The bin changed direction and speed. She used a hard push, she used a hard pull, and her bin tipped over. That's what happened to my box too. Also, one of her handles came off. Oh no, she needs to make it better. What can she do? Oh, look at that big Lego mess. Remy asked herself questions. Are the handles on tight? Are the wheels turning? Is the bin the right size? Is there too much in it? Remy answered the questions and she fixed one problem at a time. She tested it again. It was better. She liked her design. Now it's time for the last step. You will make your design better. You will improve it. How can you make your design better? Watch this video to find out more. Answer these questions. Why do you need to improve your design? How can you use brainstorming or thinking of ideas to improve your design? And what is one improvement that you can make to your design? Explain it. So when you're making your design better, you can answer these questions too. What problem do you see with what you made? And how will you make it better? How will you find out if the change you do make does make it better? So you're going to put this in your science journal. You're going to work with your learning coach. You can draw a picture of the change you make and you can complete some sentences about it. After you do your improve section, you're going to see if that new improved design works even better. Yay! You made a bin for your stuff. You asked questions. You thought of ideas. You planned it. You built it. You tested it. You found ways to make it better. You did the whole engineering design process. Now we just need to reflect on how it worked. Down here, you can put the steps in the engineering design process in order, those steps on that chart that you just saw to make sure that you remember them. And then in your science journal, you can write a short sentence reflecting and thinking about your portfolio project. Here are some sentence starters. You can also draw a picture if you would like to draw a picture as well. So here are both of those last 2 sections that I put in my science journal. For improve, I said one way I fixed my box was moving my string up higher. So it was tipping over because it was jerking the bottom. So I lifted it up and I tied it at a higher point. That was the improvement I made to my box. And for my reflection, I said I learned that soft pushes and pulls moved my box the best. So even with those improvements, I still didn't want to jerk and do those hard pushes and pulls because it was still very difficult and hard for my box. I had to put extra tape on it to make sure it didn't fall apart. All right, so let's look back at your lesson. This is the last part. We just need to make sure that we have everything. So when you get ready to turn in your portfolio, we need to make sure we have all 8 parts. Number 1 is the science journal that asks questions. That's going to be this worksheet right here, the storage bin. So if you've got your storage bin, that's your ask questions section. That's what you're going to use. All right, for number 2, you need your T chart where you did your brainstorming. That was this one, right? When we had our needs and then we had our ideas. Remember, you want to have at least 2 or 3 of those in each section. All right, what do we need for number 3? For number 3, we need your draw and write where you made your design. So you've got that draw and write printable worksheet. It looks like this. You've got your drawing up here and then you've got your writing down here. All right, next you are going to need the steps to create your bin or your timeline. That's the one that looks like this where we numbered the steps 1, 2, 3, 4, 5, however many steps you need for your creation. And then number 5, pictures of your bin or your box. So you can make this out of anything. For my box, I used a simple cardboard box and I used that string to do those pushes and those pulls. And I also pushed down on that top and I reinforced it with that extra tape, especially in the corners to make it stronger so that it didn't fall apart. So you're just going to want pictures that can be very simple, very easy of your design to turn in with your portfolio as well. After you did your design, remember we did that 2-column chart to talk about how it did when it was tested with those soft pushes and soft pulls. You're going to want to turn that in as well. And then in your science journal, you want your improve section and your reflect section. Remember, there should just be a sentence for each of those. So here's this rubric that we can look at before you turn it in. On the next page is your Dropbox, where you're going to turn that into your teacher. But let's look at that rubric really quick just to make sure that we did everything. The first section is ask questions. Yep, we did that. That's the concept web. The next one is brainstorming. We did that. That was that first T chart. Our design, that was the draw and write worksheet. And when we actually made it and create, right, those are those pictures showing that you created it and that 1-page timeline showing those steps. Our test, that's that 2-column chart with the soft pushes, soft pulls, hard pulls, and our improve and reflect section that we wrote down a short sentence or two showing what we improved and how we felt about it. So it looks like you've got everything. Make sure that you gather it all up together and turn it all in at the same time to your teacher in that Dropbox. I know that you did a fabulous job. I'm so excited that you're an engineer now, and I am too. High five. I will see you next time. Thank you so much for watching. I hope this was helpful. Have a good day. Goodbye.